Well, students, we were talking about sedimentation. इसमें we have talked about plain sedimentation, and then we will be having some combined sedimentation as well, जिसमें flocculation और coagulation दोनों combined work करेंगे. Basic जो purpose है, we talked about that. वो that is about the settlement of the higher density particles. And if the particles have not higher density, उनकी density को higher करने के लिए we are going to use some coagulants जो कि उनको combine करेंगे, उनको they will coagulate, and then they will increase their density, and then it will settle down. So this is some process जो कि हम बाद में detail में discuss करेंगे. And then this is one of the sedimentation tanks, you can see here. And then we have flotation process as well. So this is kind of reverse. पहले था sedimentation में कि higher density के through हमने particles को settle down करवाया, and then we obtained it in the form of sludge. Now this is something about the flotation. इसके लिए the particles and the waste material जो कि lighter है density में है, it will float on the surface. स्पेसिफिकली अगर आप बात करें जो हमारे ऑयल्स हैं, ऑयल स्पिलेज है, उसकी जो डेंसिटी है नॉर्मली वाटर से लेसर होगी, एंड इट विल बी फ्लोटिंग ऑन द सरफेस. सो वी कैन हैव सम मैकेनिज़्म. नॉर्मली स्किमिंग इज़ द मैकेनिज़्म जिसके थ्रू हम इसको सरफेस से जो है वो रिमूव करते हैं, ऑयल सेपरेशन, वाटर सेपरेशन. सो efficiency it can be improved by blowing air through the liquid. इसके लिए ये है कि we have some mechanism जिसमें हम एयर को इंट्रोड्यूस करवाते हैं into the system, and by this process we will be having some better performance, and जो कि lighter particles को surface पे ले आते हैं, and then from where we will be removing them. डिफरेंट जो सेपरेटर्स हैं, नॉर्मली एरेशन का जो प्रोसेस है उसको जब हम स्टडी करेंगे तो उसमें वी विल बी टॉकिंग अबाउट डिफरेंट टेक्निक्स, जैसे किसके थ्रू हमने एरेशन करनी है. सो एरेशन इज़ इम्पॉर्टेंट. सो उसकी डिफरेंट एप्लीकेशंस हैं, लाइक अभी आपने देखा फॉर द फ्लोटेशन पर्पस भी रिक्वायर्ड है. फिर हमने एयर जो है वो सम पर्पस जो कि ऑक्सीडेशन के पर्पस को इन्हांस करने के लिए भी वी आर गोइंग टू एरेट आवर वेस्ट वाटर. सो उसके लिए अगेन वी हैव सम मैकेनिज़्म, डिफरेंट टाइप्स ऑफ एरेटर्स जो है वो हम यूज़ करते हैं नोजल्स के थ्रू, एंड देन वो हम इन डिटेल डिस्कस करेंगे. And then drying and evaporation is one of the procedures, physical procedures actually. So these are the approaches, किस तरह से हमने sludge को जो है वो dry करना है, evaporate करना है. You can go through them by yourself, and these are the chemical processes now. इसमें हमारा जो मेन फोकस है, अगर आप देखें तो नॉर्मली रिडक्शन एंड ऑक्सीडेशन आर द मोस्ट कॉमनली यूज्ड प्रोसेसेस. न्यूट्रलाइजेशन इज़ अनदर प्रोसेस, एंड देन वी हैव प्रेसिपिटेशन जो कि केमिकली सेटल डाउन करती है बाय डेवलपिंग सम प्रेसिपिटेट. रिडक्शन एंड ऑक्सीडेशन का अगर आप प्रोसेस देख रहे हैं तो वी विल बी रिक्वायरिंग सम ऑक्सीडाइजिंग रिएजेंट्स, रिड्यूसिंग रिएजेंट्स विल बी रिक्वायर्ड. सो उनमें जो कॉमन एग्जांपल्स हैं वो आपके सामने हैं इधर. यू कैन गो थ्रू दीज एग्जांपल्स ऑफ reagents for both oxidizing and reducing. So by the way, what is a reduction and what is an oxidation process? So in an oxidation process we are losing the electrons are being lost. हमारे जितने भी जो processes हैं oxidation के, we are requiring some component which will be acting, which will be added up, and as a result of that we will be getting a loss in the electrons. Similarly, in case of reduction, we will be having an addition of the electrons. इसकी एग्जांपल्स अभी आगे जाके हम देखते हैं क्रोमियम की फॉर्म में. So oxidation in practice needs expert design, careful operation, and then cyanides. Reduction in process in practice. So नॉर्मली हमने बात की हुई है लास्ट टाइम भी इन आवर प्रीवियस कोर्स. क्रोमियम हेक्सावेलेंट एंड क्रोमियम ट्राइवेलेंट both are different oxidation ionic states of chromium radical, and the best approach to remove this chromium is the precipitation. और उसके लिए we need to reduce. जैसे हमने पहले भी बात की हुई है कि क्रोमियम हेक्सावेलेंट इज़ इन द फॉर्म ऑफ फ्रेश, इज कमिंग फ्रॉम फ्रेश सोर्स, and with the passage of time it will get reduced because of the reaction with hydrogen or some other ionic radicals, and then we will get the reduced trivalent chromium. Now this reduced trivalent chromium is less toxic than the hexavalent chromium, and then finally it will, and it is not a reactive compound, trivalent chromium, and then it will be because it is more stable. So because of this stability it is going to develop precipitation, and then it will be settling down and we can remove it once it's settled down. न्यूट्रलाइजेशन इज़ another process जो कि बैच प्रोसेस है. सो व्हाट इज़ अ बैच प्रोसेस? इट इज़ actually a step-wise process. So when we are doing some process in different components, different steps, it will be normally having a batch process. So it cannot be accumulative, but it is basically to neutralize. So if we are having higher acidity or alkalinity, then neutralization is the option left to deal with it. Acid waste are neutralized by alkalis and vice versa. This is the summary of it. Used to treat liquid waste, sludge, gas, and reactions must be laboratory tested to control pH. And so then we have a precipitation जो कि soluble and stable जो solutions हैं उनको less soluble and insoluble में convert करते हैं, and then it get precipitated. So you can, I think, go through it. Other chemical processes: hydrolysis, electrolysis, dechlorination, defluoridization, chlorolysis. Combined physical and chemical processes, it includes solvent extraction and coagulation and flocculation. So there are some physical chemical treatments. Waste from industrial process is entering, and then we have physical and chemical treatment, and here is the list which will be involved, which include oxidation reduction, ozonization, precipitation, neutralization, adsorption, hydrolysis, flocculation, coagulation, filtration, and ultrafiltration. So all these processes will be taking place in these steps. And then we have some other processes which will be taking place in these processes, these steps, and then we will be having this gravity separation, dissolved air flotation, and API separation, and it will be dealing with these processes. So these are the key considerations. So please go through these slides. This was just an introduction. What kind of processes, physical and chemical, we are normally adopting in our treatment processes, and so next time we will be trying to explore more about these processes, and more importantly we will also talk about the sources like wastewater characterization. Wastewater, what is the characteristics and what kind of treatment is required. So in next lecture we will talk more about these uh, techniques. Thank you very much for today's lecture.